All right, I'm on page 61, question 1. Now, the thing about question 1 is that it was a past year test question. And I'm very, very sorry to say some of the guys walked out of this test in tears. I don't know what was going through my mind. All right. So that's a past year test question. I want to look at today question 2, because I believe that question 2 is more appropriate for understanding and getting across the first principles when it comes to concrete work and quantifying such. All right. So let's look at question 2 for now. All right, let's look at it. The drawing shows a rectangular reservoir. All right, determine quantities according to the brief specification provided. All right, so from my experience, right, so as I was saying, what I've observed over the years that when it comes to quantities, if you as a student can't make head or tail of the drawing, then you just fail in quantifying it. So let's try and understand the sketch first. All right. So we've got a rectangular reservoir. Here's the side section, and here's the top plan or plan view. All right. It is above ground, but partially submerged in terms of its flow. Goes up 15 meters, 30 meters across, and also has multiple width thicknesses for its body. So you've got wall thickness of 225, a slab thickness of 160, and within it you have columns, all right, extending from the floor all the way to the roof, basically holding up the roof, and we have 10 of them, all right, and their size is 300 by 300. So 300 by 300 columns going up all the way to the roof. And the roof has a hole in it for maintenance and for people to get in to clean, basically put in some telemetry, which allows people to know the levels without having to physically go into the reservoir to check. All right, so that's what the structure is all about. And we're given a 75 millimeter blinding layer at 15 MPa. The roof concrete is 20 MPa. Now here's something new. Use 119 kg per meter cube for 20 MPa concrete. All other concrete is 25 MPa. And for that, use 130 kg per meter cube for the 25 MPa concrete. All excavated material to be spoiled, 1.8 kilometers from site, and thankfully, do not apply surface finishes of shutters acceptable. So we're not going to be plastering or tiling this thing in. Okay, so that is in short what the question is asking of us. Now let's try and understand this practically. Okay, so here's something. Here's a floor thickness of 320, partially in the ground. All right, the walls have a thickness of 225. The roof slab is 160, also at 20 MPa. Everything else, apart from the roof, is 25 MPa, including the columns. All right, and what else? 15 meters by 15 meters by 15 meters high. All right, so that's what we basically looking at quantifying. All right, let's begin. As usual, let's start with site clearance. So let's put here first what we're working on, page 62. Now, before I start, I'm going to be doing some calculations based on my understanding. You may look at it differently and basically do it your way and still achieve or arrive at the same answer. So please don't stick by my methods when it comes to the geometry of it. You'll see in a moment what I'm talking about. Okay? Let's look at it. All right, first one. site clearance. Two, excavation. Right. Under excavation, 2.1 top soil. And we're saying 0.15 times. Now what's this effective depth? We're going 320 millimeters below the ground level, all right? But we also have to accommodate for the blinding layer, all right? But in the process, we still need to take off the topsoil, 150 mils. What is our effective depth? 245. Okay, so let's do this. Blinding. Topsoil. So if you're wondering where these numbers came from, there you go. And therefore, all right, that's normal material. Next. What happened here? Refer to previous examples. All right, first question, we go into number 4. Remember the last couple of questions, we stopped at 3. All right, 4, concrete. Now, here's our area. Here's our thickness of the blinding layer. Remember, blinding layer sitting here at 75 millimeters. All right, below the 320. All right, now please don't make this mistake, and I've seen it regularly. 100 millimeters is 0.1. Anything below the 100 millimeters, there's an extra 0. This is 75. There's the extra 0 there. All right. Now, don't, in your haste, 75 divided by I don't know what, and you get 0.75. 0.75 is 3/4 of a whole meter. All right. Throws this up considerably, and it's wrong. Okay. Careful for that dimension there. All right, now 25 MPa concrete is basically all of the structure except for the roof. All right, so let's break it down in order of construction. So we're going to put the floor first, then the walls. Yeah, not vice versa. So let's put the floor or calculate the floor concrete first. And let's be methodical and say floor concrete. And that's 450 square meters times thickness of 0.32, and we're getting 144 meter cube of floor concrete. All right, so let's look at it in terms of the sketch so that you understand how to basically break up the structure as you are quantifying. So we put on the floor, all right, concrete, and we know the floor thickness is 320. So from there to there is 320. We know this is 30, we know this is 15. All right, so by our calculations, we've got 144 meter cube of concrete. Now, on top of this we'd now cast our walls. All right, we cast our walls. Okay, so let's do the walls. All right, so let's call it, external walls. And for that, what is the height? 15 meters minus the thickness of the floor plus the thickness of the roof slab. Right? Remember from our sketch, it is completely 15 meters. Right? Can you see that? Completely 15 meters. So there's the roof, there's the floor, and I want to find this one because that's the walls. All right, now somebody's going to say, why don't you go all the way to the top and then put the roof inside? It's difficult. It's not I'm not saying it's not possible, it's difficult. All right, so we're going to basically put up our external walls and make the roof sit on top of the external walls and the columns. All right. All right. Now the sketch says we have a breadth 15 meters and a length of 30 meters. Sorry, height, effective height of 14.52 meters. So that's the section here, the blue. All right, now if I were to break up this structure into, let's call this A. So this is that entire wall. Let's call this also A because it's the same thing, just on the other side. Right? Then we'll have two equal panels, 15 meters long and 15 meters high. And if we had to say this is B, this will always be equal, also be equal, but then we know from there to there is 30. So effectively, how much of B will we be calculating for? It'll be 30 minus 2 times the thickness, which is 225. So panel B is now reduced. Or you may say, let's go the other way. Let's use B. as full panels and chop off the short ones. So this is your choice. I can't control this, all right? I can't control this. You will make these kind of assumptions to make your calculation easier for you, okay? I'm using this as my full panel and that my reduced panel. You can do vice versa. And this you will see will happen in other structures when it comes to brickwork. You'll be doing the same, I will be doing the same, you may do vice versa. You'll still arrive at the same answer, assuming all your calculations are correct. Okay? So when you're going through this answer, you're going to ask yourself, what happened? Where did he get the numbers from? Maybe for A, you'd get it. Then B, you'd get confused, but here's it, my explanation. Why the numbers are going to be less. All right, so I'm saying breadth calculation. All right, so basically now going back, I found the volume of concrete for that and that, that and that. They're all 20 MPa, oh sorry, 25 MPa, nothing to worry about there. Now, what's remaining? The columns, all right? Also same strength. So notice, they're all falling within the same calculation. Here's blinding, that's 15, finished. Here's 25, and 25 still progresses, all right? Now, don't think we're going to go 15, 20, 25, 30 in order of numerical order. No, no, no. We're going in order of construction method or construction process. All right? Because look at this. This is on the floor. So it's the lowest, 15 MPa. But then you've got 25 MPa around the walls. But when we come to the roof, it's 20 MPa. Now, if you had to do 20 MPa, it's like you're putting the roof on first before putting on the walls. That's not on. Okay? At 0.3 squared, because it's square, times 14.52.368. I don't know why I went to so many decimal places, but nevertheless, it'll be times 10 of them. So 1.307 meter cube. Final total 25 MPa. There's 10 columns, all right? That's where 10 came from. We're saying floor plus walls plus columns, and we're getting 144 plus 98 plus 193.08 plus 07, and the total 25 MPa at 448.15 meter cube. All right, now let's look at something new. Reinforcement. How do we accommodate for the reinforcement condition of the question? And it says for the 25 MPa, we're using 130 kgs per meter cube. Now, if we know the volume, then we know how much of, or the volume of concrete. Let's put your concrete, of concrete. Know the volume of concrete, then based on that, we know the volume of steel, 48.15 times 25 MBA use 130 kg per meter cube. 130 kg per meter cube. And we're finding it to be 58.26 tons. Right, remember from the lecture, steel is in tons. Right, now we've put on the roof, we put on the walls, we put on the columns. What's next? Let's put the roof on. All right, and we're still in, what do we have? Right, sorry. We're still in item 4, which is now 20 MPa roof. And we're saying, right, what's this? Right, depth of roof. All right, but also within that roof, there's a hole, a manhole. So and it's a hole basically. So it's not going to require concrete. So we need to take that off. We know the dimensions of the hole is 1 meter by 1 meter. The thickness is 0.16. And you get a volume of 71.84 meter cube of 20 MPa concrete. And while we're there, let's do the reinforcement. And we say 71.84 times 119, and we find it to be 8.55 tons. All right, so notice how methodical we are. We're going according to how we built this thing. All right, and while we at a specific spot, we actually did our reinforcement calculations, so we don't forget at some point. All right. All right, so let's bring in new item 5, and we say reinforcement. Although we've already done it, we give it its own line item, and we can say for 20 MPa, we used 8.55 tons, and for 25 MPa, we used 58.26 tons. All right, so as much as we already did the calculation, we give reinforcement its own line item in our bill of quantities. By now, the terminology line item should be familiar to you. All right, it's a line in that bill of quantities for pricing. All right, let's start with number 6 now. What could possibly be number 6? Remember, that was concrete. We need to bore it. We need shuttering to create the forms. That needs to be quantified also. What is the shuttering? Right? What is the shuttering? What is this? The shuttering now is each of these panels, that panel, that panel, that panel, that panel there, inside panels. We need to create the forms, all right, to pour the concrete in. And we're using shuttering. So I need to find the area of all this, that inside, and also all the panels here for our columns, 4 sides. All right. And then when we finish with that, we also need shuttering for the roof, basically, to hold up the roof for it to set. All right. Let's go. Now I'm going to put a little description there so you can find your way as you go. It will get confusing, but if you understand what you're trying to do and attempt it yourself and then try and base it against this, you'll understand what's happening. For now, it may seem just low numbers, but attempt it yourself, but fully understand what you're trying to calculate, and you should be fine. Like I said, I chose this example very specifically. All right. All right. Let's see now. What's the calculation columns? Think about carefully where those came from and why. All right. It's not 30. It's not 15. All right. What am I saying here? For the roof. All right. When I pour the concrete for the roof now, all right, I've got a calculation we're coming to for the shuttering to hold the concrete for the roof, right? But we still here in the calculation, we're holding up the roof. Now the roof is going to sit on that portion, but also it's going to sit on the top of the columns, isn't it? Because the columns don't, well, basically the columns go up to the soffit of the roof, right? And then we also got to subtract that hole that's in there for the manhole, right? So we're coming up with some interesting numbers here. Right, so that's basically all the items for this particular problem calculated. All right, some things here you may get lost. Think hard. All right, size of the roof. What am I talking about? Remember, we built that. All right, when we finish build that, we're going to put the roof on. But if you pour the concrete, it's going to fall out. Right, so we need more shuttering to hold it from falling out. And this is this portion here of the calculation. Right, that little thin piece that goes all around there, so we can pour the concrete so it doesn't fall out. All right, and actually these small calculations is for the shuttering for the inside of that full side. So we've got a box concrete around it, and we've got a hole helping us to get in. All right, so brings us into the calculation. All right, this is the calculation pages. All right, the calculation pages. Yeah, a lot of them. Now, I barely look at this. What I do look at is the bullet quantity. But I need to see it if you make a problem, if you have or made a human error. So let's complete this with the bullet quantities. Basically, what does it look like with all these items that we've now calculated? Because remember, we stopped at 3 in previous examples. Now we've gone up to 6. As I mentioned, your bullet quantities, your measurement list is not growing. It's almost half a page. As I mentioned earlier, when you started, it's going to go to a page or more by the time you get to your exams. All right, so let's say with quantities, get to there. Now, some of you may have observed a mistake in item 4. It's not. If you want to line it in terms of the calculation, you're free to do that. What am I talking about? I'm talking about this too. Remember, we did this calculation first and then we did that. All right? And I interchanged it. I don't care. All right? All right. You know how to fill that in by now. Now, look at what's happening here. We've got a dimension section, all right? There were multiple calculations here with so many different dimensions. Can you put them all in? No, you can't. So you need to improvise. All right. And you can put in what you got for that, what you got for that. And you can basically put in a meter cube, meter cube, meter cube. And you can put a value there, whatever you got. But what I'll be looking at is the total for that. And what did we get? 448.15 meter cube. All right. What's after that? 5. Reinforcement. And let's say in the reinforcement, easy one, 20 MPa. And tonnage, what did we get for tonnage? .55, 25 MPa. You can put here 58. Please don't do next. Do not add this up and give me one value for reinforcement. Basically, I'm saying don't give me one value for reinforcement that includes that and that, because the unit is the same, so you can't add them up. All right. I want you to break it down because I got a mark scheme and there's marks attached to that. Now, if you give me one value, then I got to go look for what is what, and that frustrates me. And you might not get the full value. Okay. So you can tally it up here if you want to. Okay. If you want to. Right. Like we did up there. No problem. But I need to see this too. And it might get complicated. I put a 30 MPa something else. So it's 3 different things. One value, different mark scheme. You may lose out. So break it down. Don't be lazy. Because you want to show me that you know what is being asked. And I want to give you the marks for what you know. Okay? So don't try to be deceptive and hide it there and let the lecturer figure it out. I'll figure it out. Yeah. 0, 0. See you next semester or next year. And the last one, where we go, shuttering. Right, shuttering, same thing. You've got, let's put in your description. Shuttering over here in your dimensions, you can put in what? Let's see, walls external, walls internal. All right. All right, columns and roof. All right, and you got values for all of them. We already did the calculations there. All right, sides of roof, sides of manhole. You know, when you do something like this, you break it down for me, I can see where you made a mistake, if you did. And I'll just take off a mark out of 12 marks. Yes, shuttering can carry 12 marks. Look at the number of calculations involved here. 12%, if it was 100, 12% is carrying out just one line item, shuttering. So break it down for me so that I can see where the numbers are coming from. And I can give you marks. But if you put in one figure there, right, now I got to go looking for this. I got 100 scripts. And this semester I got 126 of your scripts, potentially. I don't have the time. All right? You want to make it easier for me to give you marks. Don't try and hide it. You won't get anything. All right? And you've got a, what is this? Meter squared, meter squared, meter squared, meter squared. And you can have your values there. And lastly, you can say, right, that is my total shuttering, 3204.79 meters squared. And yeah, that's all it's covered. So here's the answer. All right. And if I'm marking, let's see, 4 marks there. This one here, 2, topsoil, 2. Normally you put blinding here, right? So it's 3 marks there. Overall, it's standard 3 because I need to know, this part here. And we look at concrete blinding layer for the concrete, 2 easy marks there. We moved on from 4, we went to 20 MPa. What was 20? The roof. There's some thinking involved there. 4, 25. There's a lot here. Let's see how many. 1, 2, 3. Let's put here. Floor was easy 2. Walls were hard. That's 4. Columns were easy 2. And our total here is say 1 and what's this? 4, 6, 8, 9 marks for that. Let's look at this. This is 20 MPa times volume times that now. 2 marks. 2 marks. Shuttering. Let's look at this. Walls. Okay, let's see. Walls. 2 sides. Let's see. 4 columns. 4 roof. A lot of work there. 6 sides. 1 and 1. Let's see what we're getting here. 12, 18, 19, 20 marks for that. Right, what does this question carry out of? 20, 22, 24 plus 9, 33. 33 plus 4, 37. 37, 39, 42, 45, 47, 49, 53 marks. Looking at this paper is 53 marks. Let's make it, make it 60. 7 marks. Let me add some more here. Let's make this 2. Let's make this 2. And make that 3. Let's make that 3, 3. Now you can see how I came up with the numbers. All right. If you want to know where I get these numbers from. All right. But I'm not the type to go higher. I actually go lower. So something for you to think about. Anyway, that's just to give you an idea of the mark scheme. But this is what I'm marking. Can you see what I'm marking? Did I even go to this? I will go to this if there is a screw up somewhere here. If there's a mess up, I will miss. That's why I need this. Okay? All right, so very good question. Confusing because of the geometry, which you need to figure out for yourself, and multiple items brought in here. Remember the last couple of questions, we stopped at 3. Now, I've added so much in one question. Not hard at all, but so much. All right? After shuttering, we're going to look at steel. If there's a steel roof, then we're going to start quantifying steel roof just to prepare you. Right? If there's steel roof and if there's paving, and there usually is, then paving is another length of measurements or for your measurement list. All right, probably your measurement list is sitting there at steel plus roadworks. Your measurement list is going to stop here by the time you finish a proper full example. All right, see you on the other side.